So when you're given a question like this, we need to figure out the right substitution. And the strategy of substitution is always around what is given in the function. So whenever you look at the simple integrals that such as f dash x over fx time, when we did, there was a rationale behind like this particular question is that when you have the derivative of function in the numerator as multiplier and whatever the f of x is, you can substitute for that particular function. Now, for example, if I have, let's say, uh, f dash x here times e to the power f of x or something like that, I can substitute still for f of x as some other variable. So if you have a function, um, given function, as its derivative here as a multiplier. So let's say f dash x is a multiplier, and you can take that, you can substitute something whose derivative is a multiplier. Now, for example, if I take, for example, let's say the favorite variable that we substitute is u. Let's say if we take u is 3x cubed plus 5. So when you have u is 3x cubed plus 5, now derivative of u is 6x squared. Now what is the correct direction is that you figure out that where at least the variable which is x squared I should have as a multiplier. So when you substitute for a particular expression, make sure that at least the variable of that substitution, I mean, when you take the derivative of that u, it's whatever the answer you get, it should be multiplied along with the function. Now, what I mean to say is, like, for example, let's say u is 3x cubed plus 5, the derivative is 6x squared. At least I have x squared here. It's okay if you don't have the exact derivative, like here. Even if you have the variable, that should work. Now, let me give you another example. Integration is not done yet. So let us take another example. Let us take example where something like, okay, e to the power sine x times cos x dx. Now here, let's say if I make the substitution, first thing that goes wrong is that people make entire substitution. So e to the power sine x, if I take it as u, the derivative of this is different. So du by dx, when you do for this, it is e to the power cos x times negative sine x, which is I don't have as a multiplier. So how do we do this then? So in logical senses, you substitute something whose derivative exists. If not the exact, at least the variable should be there. So now, for example, instead of taking the entire substitution, what if I take u as sine x? Now, du by dx will be cos x, and which is here. So that's something which we wanted. And then let us take another example. For example, if I have one of the favorite one that comes as a in the exams are um, for tan x. Not for tan x, it's obviously we can use the previous logic of f dash x over fx. But see, I can write down tan x as sine x over cos x. And then if I take cos x as u, let u be cos x, at least its derivative is du by dx is sine x, negative sine x. At least it is multiplied in the numerator. So if you have the derivative structure multiplied along with the function, the substitution process becomes easier. So let's take, for these three questions, let's understand our substitution procedure. So let's take one more example also, x cubed over x to the power 4 plus 7 to the power 8. So these are the four questions. Let's try to understand how do we do using substitution. So number one is when you identify the substitution, just to assure that at least you have its variable derivative, derivative of that variable which is substituted is as a multiplier along with the function. So now let us say when I take u as, when you take u as 3x cubed plus 5, it becomes really important that you replace this dx. Now, because if you're taking in terms of other variable, it is important that now the integration is no more with respect to x, because you're entirely changing the backbone structure or skeleton of the equation. What happens is that you need to replace this dx in terms of u, so in terms of du. So your integral now no more should be in terms of x, it should be in terms of u. So how do we get rid of this dx? So if I take du by dx, guys, here, I get, let's say, 9x squared. And you know what we do is, next we make dx the subject. So dx, if I make the subject, you get du over 9x squared, and you put it out here. Now, why did we search for that derivative in the beginning is for the reason I'll figure out. So when I do that, let's say I don't have anything for x squared. I know this entire thing is e to the power u, and now du over 3 and du over 9x squared. So what happened is that this x squared and x squared actually get cancelled, and that's where we were looking forward, that at least I should have the variable of that derivative, at least the derivative of that variable should be as a multiplier, so that we can strike out this x squared term. So now if you look at, I get the integral as 1 over u e to the power u du. Now this can be easily done. Now you know the integration of e to the power u is e to the power u itself. So you integrate and put plus c, and then substitute back the original equation, which is 1/9 e to the power 3x cubed plus 5, and of course plus c. So this is your first integration by substitution question. So now next up is when you are integrating e to the power sine x times cos x. So here, let u equals to sine x, because its derivative I can see is at least cos x. So du by dx is going to be cos x. You're differentiating u with respect to x, which means derivative sine x with respect to x is cos x. So so dx is going to be du over cos x. That comes out here. Don't forget to replace this dx, otherwise your everything is going to be wrong. So e to the power u times cos x times du over cos x. So this cancellations. So e to the power u du, and now what we get is integration of e to the power u once again is e to the power u plus c, which means that integration of this is e to the power sine x plus c. So now if I have, let's say, integration of tan x is sine x over cos x. So I mean, you can write down this as tan x can be written as sine x over cos x. And first thing that will be important is that what substitution do we make here? So obviously the derivative of that substitution should be in the numerator. So let's say if I take u as cos x, du by dx is negative sine x. Now, since derivative of negative sine x, derivative cos x is negative sine x. If you make dx a subject, you get du over negative sine x. And you substitute out here, so it'll become integration of sine x over u times du over negative sine x. So this cancels out, and you get negative du over u. Now, negative du over u will be negative ln u, because 1 over u integral is ln u plus c. And of course, then, because you took u as sine x, it'll be negative ln sine x, negative ln cos x, because u was cos x, and plus c. So this is the derivative or integration of this, which can be, if you use the log property and bring back in the power, it becomes negative, so ln sec x plus c. So that's the integral of the tan x, which you can remember as a rule, that integration of ln sec integration of tan x is ln sec x, which can be a quicker way of remembering this. So now next up is, let's say if you have u as x to the power 4 plus 7. Now du by dx will be 4x cubed. Now here, I'm not taking entire to the power 8 because that derivative I don't have. So I have to just be selective. Either I can take x to the power 4 only, or you can take entire thing. That doesn't make a difference. So now dx can be written as du over 4x cubed. So you plug out here. So as a result of that, will become x cubed over u to the power 8 times du over 4x cubed. X cubed and x cubed get cancelled, which we get is 1/4 integration of du over u to the power 8. Now then after this, it will become 1/4 integral u to the power negative 8 du, which you simplify as 1/4 u to the power negative 7 over negative 7 plus c, and of course you substitute back the value of u. So I'll just rewrite this here. So let's say integral is going to be negative 1 over 28 and x to the power 4 plus 7 to the power of 7 plus c. Because if you bring it down in the new denominator, it becomes the positive exponent. So that's how you do the integration by substitution basic questions.